Hi guys. So let us start the second video in the trigonometry unit. Suppose we have been given two angles. Let us say one angle is 30 degrees and second angle is 60 degrees, right? And I need to find out sine of 30 plus 60 degrees. Okay. I know that this 30 plus 60 is basically 90. So sine 90 is equal to 1. So for sine 30 plus 60, the answer has to be 1. This is for sure. But it is very tempting that if in case of let us say 30, we do not know the answer. In place of 30, we have been given just an angle theta, right? So if it is written like theta plus 60, so it is very tempting that we multiply this sine with first theta and then with 60 degrees, right? This is very tempting, although it is not equal to, and this is the case that we have to prove that this is not equal to sine 30, sine theta plus sine 60. Okay, we cannot do this because what we have done here is we have just applied the distributive law here that this sine will be multiplied by theta and then plus sine will be multiplied by 60, right? If this sine without any angle means if I just write this sine, it is just a function without any input to this, without any angle, whether it is in radians or degrees, this sine has no meaning, right? If you just say that sine, what is sine? It is nothing. Okay, until and unless you give some angle to this, that sine of 45 degrees, sine of 50 degrees, sine of 60 degrees, or sine pi in radians, whatever is the angle. So if you are not giving any angle, sine has no meaning. It has to be sine of some input, sine of some angle, right? Then only you can draw the graph of sine x and so on. Then only it has some meaning, right? So if you are considering this sine only sine as a number or anything which has some meaning, then only you are multiplying this sine, you are multiplying this with theta and then multiplying this with 60. Okay, although we are not multiplying here. If it is written sine 30, so sine is not multiplied with 30. Okay, but it is very tempting, and it appears that we need to multiply this sine with first 30 and then with 60 degrees. Okay, so let us prove this. If it is at all, we have to multiply this with 30 degree and 60 degrees. So what we need to do is, let us take the same case here, 30 and 60. So let us multiply this. I am taking left hand side sine 30 degrees and plus sine 60 degrees. If you are multiplying this, so sine 30 is 1 by 2 and sine 60 is root 3 over 2, which is basically root 3 plus 1 over 2. Okay, and of course this is not equal to 1 because sine 30 plus 60 is in fact 90 and sine 90 is 1. Okay, that means this sine LHS, this is not equal to sine of 30 plus 60. Okay, that means we cannot multiply this sine with 30 plus sine with 60. So this is not multiplication basically. So what we need to do, if we have in any trigonometric identities, in any trigonometric equation, right, in any trigonometric expression, if it is given that theta plus 60 or theta plus 30, so how to deal these two angles 30 and theta, right? So we need some mechanism, we need some, you can say, formula to deal with these theta and 30 degrees separately. Right now these are combined with, this is just one angle. One angle is unknown, theta plus 30 degrees, because we know the value of sine 30. So we need some mechanism to separate this theta and 30 degrees. Okay, and that mechanism, you can say, is what is our next topic, that is compound angle formula. So this angle, we say that this is in compound form. Compound means addition form, right, when more than one angle is involved. Okay, so what will be the formula for sine theta plus 30 in this case? Okay, so here we have a compound angle formula. So this is given by sine theta plus phi is in fact not sine theta plus sine phi, it is sine theta cos phi plus cos theta sine phi, right? So let us quickly derive how we have arrived at this formula, right? So we have been given a triangle ABC, which is right angle at D, not right angle at D. We have been given an altitude CD, right? So this is the height of this triangle whose base is AB, and this is your theta angle, and this small angle is phi angle, and this whole angle is theta plus phi, means angle ACB is theta plus phi, right? And these sides are A and B. Okay, so how we can derive this? So let us quickly derive. If I say that what will be the area of triangle ABC, ABC means this bigger triangle ABC. It is half base into height. Of course, it is half base into height, but we have another formula if we know the sides A and B and an angle which is including these, which is included within these two sides A and B. Right? So area of triangle here is half AB sine theta. This formula we are using. Theta means if in any triangle this is A, this is B, and this is B, and this angle is theta. Okay, so half AB sine theta, this formula we are using. In this case, in case of theta, we have theta plus phi. Okay, this angle, whole angle C is theta plus phi. So half AB sine of theta plus phi. Okay, this is your left hand side, means area of triangle ABC. Now, as we drop this perpendicular from C to the base AB, whole triangle is divided into two smaller triangles like this. Okay, that means this whole area ABC is summation of area of triangle ADC, this ADC and BDC, plus area of triangle BDC. Okay, so these two smaller triangles. So now we find out the area of triangle ADC, which is half base of this triangle is AD and height is H, plus half base of this right side triangle is DB or BD and height is H, right? Now, in the smaller triangle, we have to replace this AD in terms of either B or A, right? So this AD, I can write, let me show you this AD. This AD, and this is a right angle triangle whose angle is theta and opposite is AD, right? So using the sine formula, which is opposite upon hypotenuse, I can write AD as B sine theta. Okay, so I'm writing this equal to half AD as B sine theta into H, okay, plus half BD will be A sine phi into H, right? Now we need to remove this H also, because on our left hand side we have A, we have B, there is no H in the left hand side. First thing is this. Secondly, if you have to derive the formula, so in the area of triangle ABC we have arrived at this function sine theta plus phi. This expression we have arrived at, okay, sine theta plus phi. That means we have to remove this half AB somehow, right? And this is the process that we are doing, that we have to remove this half AB so that we get only sine and cos terms, right? So on our LHS we have half AB. That means half AB needs to be cancelled from right hand side also, right? From right hand side also this half AB should be there. B is already there in this first expression. We need to involve A here, right? Similarly, in the second, this expression, second term of RHS, A is there. So we need to introduce B somehow, right? And that can be introduced only if we replace H or write H in terms of B, and here I should write H in terms of A, right? To involve A in both these terms, AB, right? To make these to both the terms in terms of AB, right? So H I will write here, though we are talking about this triangle ADC, right? This triangle ADC, and this term is corresponding to first triangle ADC, but here I will write H in terms of other triangle, right? Means in terms of A, right? So in this triangle DBC, I can write H as A cos phi, okay, because as I have told earlier that I need to involve A, right, in the first term and B in the second term. right? So I will replace the h of first term with a cos phi so that a and b both are there, right? So I will write this as half ab sin theta as it is, b as it is, and h I have replaced with a cos phi. So a is here and here it is cos phi, right? Similarly, in the second term, a is already there, so I will replace this h from the first triangle, which is that h is also b cos theta. Okay. So in the second term, I will write a as it is, sin phi as it is, and h as b cos theta. Sin phi as it is and cos theta I have introduced. Right? This is your RHS, and on LHS I have half AB sin theta plus phi. Okay. Now I have half AB here. I have this half AB here. I have half AB here and half AB in the first. So these half AB and half AB will get cancelled out. You will arrive at the solution or the final formula for sin theta plus phi, which you need to remember. This is sin theta cos phi plus cos theta sin phi. Okay, first you will evaluate sin theta, then evaluate cos phi, and plus cos theta and then sin phi. Okay, so this you need to remember, I think, though although there are other formulas also, compound angle formulas, which we will derive just now. No need to do such a long process. It is just replacement of theta and phi with some minus theta and minus phi. Okay, so this is our first compound angle formula. Second formula we can arrive, which is of sin theta minus phi. Instead of plus, if I write minus phi, so what change it will give in this formula is that since phi becomes minus phi, so in the first term this sin theta will remain theta, but phi will be minus phi. So cos minus phi is basically cos phi. Okay, so this whole term will remain same because cos minus theta will remain as plus cos theta. Second term will be cos theta and sin minus phi. Sin minus phi means minus sin phi, right? So basically end result is that this plus will change to minus the moment we take this plus phi as minus phi. So I am just writing this minus sign here. Only change it will bring in the formula is that this plus sign will be replaced by minus sign. So sin theta minus phi is sin theta cos phi minus cos theta sin phi. Fine. One more formula we can derive, that we have sin theta plus phi as sin theta cos phi plus cos theta sin phi. Now in this formula you replace phi with not phi, you write theta as 90 minus theta. Okay, we can replace theta with 90 minus theta and let us see what change it will bring to the formula. This will result in sin theta is now replaced with 90 minus phi, 90 minus theta. So 90 minus theta minus phi I will write like this. Okay, 90 minus theta plus phi, that means theta is replaced with 90 minus theta. This is equal to sin 90 minus theta cos phi plus cos 90 minus theta sin phi. Okay, so sin 90 minus something is cos something. So cos of theta minus phi is sin 90 minus theta is cos theta cos phi, and this is sin theta sin phi. Okay, so this is your second compound formula, not the second, third compound formula for cos. And in the same you can replace minus phi with plus phi, or phi with minus phi. This will be plus phi, this will be again plus cos phi, and here it will be minus sin phi. So if I introduce this plus here, this will be minus here. Okay, so in cos this sign will be reversed. If it is minus, it is plus. If it is plus, it is minus, right? So we have derived 4 formulas from one basic formula, right? Similarly, we can derive the formulas for tan theta minus alpha or tan theta minus phi and tan theta plus phi by writing tan as sine upon cos. Okay, so here we have these 6 basic formulas. The summary of these 6 formulas is there. You need to remember only one formula if you have to, otherwise these will be provided in MF19. But I recommend that you learn these formulas because they will be used in further integration, I think, and I think means all these formulas, they are useful in integration also. Okay, it will be helpful if you remember these formulas, right?